Section 10.3.15-T. In a study, researchers wanted to measure the effect of alcohol on the hippocampal region, the portion of the brain responsible for long-term memory storage in adolescence. The researchers randomly selected 16 adolescents with alcohol use disorders to determine whether the hippocampal volumes in the alcoholic adolescents were less than the normal volume of 9.02 cubic centimeters. An analysis of the sample data revealed that the hippocampal volume is approximately normal with no outliers, and the sample mean is equal to 8.36 cubic centimeters, and the sample standard deviation is 0.7 cubic centimeters. We want to conduct the appropriate test at the alpha equals 0.05 level of significance. Well, the first thing we need to do is we need to check the requirements. Okay, now remember that the requirements tells us the following. Okay, it says here that the sample is obtained by a simple random sample or the data result from a randomized experiment. Well, we can see here that the researchers randomly selected 16 adolescents, so that means that it takes this part here of the requirements. Okay, and then it says the sample comes from a population that is normally distributed with no outliers, or the sample size n is large, meaning greater than or equal to 30. Well, 16 is not greater than or equal to 30, but it's telling us that it is approximately normal. So it satisfies the first part of that requirement. Okay, and then it says the sample values are independent of each other. This means the sample size is no more than 5% of the population size, and therefore they are independent of each other. Okay, now the next thing that we want to do is we want to be able to find the null and the alternative hypothesis. So we want to find the null and the alternative hypothesis. Now recall that the alternative hypothesis has the claim, and the claim states in the second sentence that the researchers randomly selected 16 adolescents with alcohol use disorders to determine whether the hippocampal volumes in alcoholic adolescents were less than the normal volume. So what it's saying here is that here is our claim. It says less than the normal volume of 9.02 cubic centimeters. Okay, so now we know that we can state that the mu is going to be less than 9.02. And then we know that the null is always going to have the equality, so the null is going to equal then, mu is going to equal 9.02. Okay, so next, what does this tell us? Well, this tells us what kind of a tail. Well, since it's less than, we know it's going to be a left tail. Okay, and then in step number 4, okay, what is the significance level? Well, in the problem, it's telling us that the testing at a 0.05 significant level. So we know that the significant level is 0.05. Okay, so now what we want to do is we want to be able to determine the test statistic. Okay, so here is the formula for the test statistic. Okay, so if this is the formula, then what we need to know is what is the mean of our problem. Well, we know the mean is given as 8.36 cubic centimeters, so we know it's 8.36, that's the sample mean. We also know that the sample standard deviation is equal to 0.7 cubic centimeters. And we also know that the sample size is equal to 16, and we know that the claim value, and the claim value would be mu subscript 0 is going to equal 9.02. Okay, so now what we're going to do is we're going to plug this information into our formula to find the test statistic. So we know that we have 8.36, and then we're going to subtract 9.02, and then we're going to divide that by the sample standard deviation of 0.7, and then divide that by the square root of 16. Okay, so let's go ahead and do that. We'll put that in our calculator here. So we have 8.36 minus 9.02. And then we're going to divide that by parentheses 0.7 divided by the square root of 16, which is 4. And that gives us that value there. So let me go ahead and copy that. So this is the answer that we get from our calculator. And then we need to round this to 2 decimal places. So it's negative 3.77. Okay. So now what we're going to do is we need to find the p-value. But in order to understand how to find the p-value, we need to draw our bell curve. Okay, and recall that we have our bell curve, and we know that negative 3.77 is located here. Okay, and so what we want to do is we want to be able to find the area that is located here. So this is the p-value that we want. Okay, so how do we do that? Well, we can now go to our table of values, but the one thing that we need to do in order to find that p-value is that we need to look at the degrees of freedom. Okay, and the degrees of freedom is taking the sample size and subtracting 1. The sample size in our problem is 16. So we need to subtract 1 to get 15. Okay. So now what we're going to do is we need to go to this chart down here. Okay. And we need to look at, okay, the value of negative 3.77. Now, if you notice here, all the values in this t distribution are all positive. So we're going to have to use the positive values of negative 3.77. Okay. And then we also need to use the degrees of freedom of 15. So let's take a look here. So the degrees of freedom is 15. So there is our degrees of freedom. So let's follow across all the way until you see where 3.77 is going to be in between. Well, we can see it's going to be in between these two values here. Okay, so what that's telling us is that it's going to be in between this value and this value, 0.01 and 0.005. So we can see that the p-value is going to be in between 0.001 and 0.005. But if you notice 3.77, it's closer to this value. So, since we know that 3.77 is closer to, in this case here, 3.733, then we're going to say that the p-value is then equal to 0.001. So therefore, there is the p-value. Okay? So now that we have the p-value, now we need to determine what is our conclusion. So now let's go to step number 7. And so step number 7 is going to give us the conclusion. So we need to compare the p-value with the significant level of 0.05. So let's take a look here. So what it states here is that if the p-value, which the p-value that we got is 0.001, okay, is it less than 0.05? Well, that is true. And if it's true, then we're going to reject the null hypothesis. So we reject the null hypothesis, and then we say that there is sufficient evidence to claim that the mean hippocampal volume is less than 9.02 cubic centimeters. Okay. Now, if we wanted to find the p-value using the calculator, okay, so I'm going to show you the calculator version. So if I wanted to find the p-value here with the TI-84, okay, well then this is what I would have to do. I'm going to go into my calculator, okay, and then I'm going to go ahead and I'm going to select second distribution, and then I'm going to scroll down to where it says TCDF, okay. So in this case here, when you're finding this area, like in order to use the TI-84, you're looking for the area to the right. So that means you're going to go from negative 3.77 all the way to 99999. Okay, so what you would do here is you're finding the area to the right, so you're going to use TCDF, which is cumulative, right? And we're starting at negative 3.77. We're going to 9999 with the degrees of freedom of 15. Okay, so let me go ahead and just bring that down a little bit. So if you wanted to find the TCDF, in this case, this is the lower bound, this is the upper bound, and then this is degrees of freedom. Okay, so let's see what we get here. So when we go ahead and then paste this into our calculator, then we get the following number. Okay, so here is our area. All right, but what we want to do is, this is the area to the right of the curve. We want to find the area here that's red. So in order to do that, we're going to take 1 and then we're going to subtract that value. So when we take 1 and then we're going to subtract that answer that we got, then we're going to get the following. We're going to get this value here. Okay, and so basically what this is that this means that I'm moving to the left 4 decimal places from where the decimal point is, because this is scientific notation. So this is going to be 0.000 and then 92676482447. And if we round that to 3 decimal places here, then that would give us 0.001. Okay, so that's how to find the p-value if you want to use that information. Okay, now in this case, since it doesn't give you p-values, you're going to have to use this table here. Okay, so that's how we find the p-value using a TI-84 calculator. Okay, now let's try to find this information when we're using the TI calculator function. Okay, and then we'll do Statcrunch as well. So if I want to use the TI-84, okay, what I'm going to do is I'm going to go ahead and go to our calculator. Okay, and so I'm going to go ahead and see where it says stat. You're going to select stat, and then you're going to scroll to the right where it says tests. And then we're going to be using the t-test because we found the t statistic. So we're going to go to option number 2 and then press enter. Okay, now in our example, we don't have data, we got stats. So we're going to select stats and then hit enter. And then what is the claim value? U subscript 0. Well, if we go back up here, we have that information in step 5. We know that that's going to be 9.02 0.02. We scroll down to the sample mean, that is 8.36. And then the sample standard deviation is 0.7. And then we also know that the value of n is 16. Okay, and then if we take a look further, we can see that the alternative is less than, so we got to go down here and then make sure we press enter, and then we got to select calculate. Okay, so let me bring the calculator information down here, and if you notice from our information, okay, you can see that from using the TI-84, we end up getting the test statistic to be negative 3.77. And if you notice, the p-value was 9.2406 times 10 to the negative 4, which was what we got here when we took 1 and subtracted that. And we moved it over 4 decimal places to get the p-value here. So we can do that by using the TI-84. Okay, now how would we do that? By using Statcrunch. Okay, let's go ahead and use Statcrunch. So if I wanted to use Statcrunch, then what I would want to do then first here is I want to make sure I have my information here. So I'm going to go to Stat, and then Stat, I'm going to go all the way down to T-Stats, and then I'm going to go to one sample, and then I'm going to go ahead with Summary. Okay, we know that our sample mean is 8.36. We know that our sample standard deviation is 0.7. And we know that our sample size is going to be 16. And then down here, we take a look at the null and the alternative. We can see that the null is where mu is equal to 9.02. And then we know that the alternative, where it's going to be less than 9.02. And then we're going to go ahead and then select compute. And then selecting compute is going to give us this information. So by using Statcrunch, again, you will notice the following scenarios. Okay, you can see that your test statistic is negative 3.77. The p-value here was 0.001. Here is the test statistic, which is negative 3.77. And the p-value is rounded to 3 decimal places, is 0.001.